Hello and welcome to today's lesson on rational functions. We're going to be covering the topics under the Algebra 2 Standard 2.7 A, B, C, and D. And we're also going to be looking at questions under the Study Island lesson Rational Functions. And as always, please be taking notes as you're going through this video. There's going to be some rules that you're going to need to study and remember so that you can be successful with these questions on your EOI. And as always, you can always pause at the beginning of the question, work it out yourself, and then in order to check yourself, watch how I do the question and see if you get the same answer. And that way you can get a gauge of how well you're learning this and what you still need to learn. But I'm so glad that you're here, and let's go ahead and look at some questions.
This problem here is asking us to solve this rational equation. So I'm going to follow my typical solving equation steps. So the first thing I'm going to do is remove the parentheses by distributing. And so what this is when I distribute that, it's placing an x squared underneath each one of these terms. And so here, x to the fourth over x to the second, that's going to reduce to x to the second. Minus, and then negative 19x to the third over x to the second, that's going to cancel out two of the x's on the top and just leave you with minus 19x. And then here the x squareds just cancel and I'm left with plus 84 equals 0. And now I'm solving a quadratic equation. So you could use completing the square, graphing, factoring, or quadratic equation, whichever method you're most comfortable with. Seeing that I have all whole numbers here, and it gives me, I'm going to go ahead and factor it, and it pretty much gives me a couple of choices, plus or minus 14 with a plus or minus 24, or a plus or minus 7 with a plus or minus 12. So that really helps with knowing what numbers to try with factoring. And this is going to factor into x minus 7 and x minus 12 equals 0. And then to continue solving, I set each of those parentheses equal to 0. And I'm going to add 7 to both sides. And then add 12 to both sides on the other equation. And then I get x equals 7, and then I get x equals 12. Which makes my final answer C. Here I'm solving another rational equation, but on this side I have two fractions equal to one fraction. It's always my goal when I'm solving and I have fractions to get one fraction equal to one fraction. So I want to see how can I combine this left side into one fraction. Well, it's subtracting fractions, and remember when you're subtracting fractions you need a common denominator, bottom, and these are both x, so I've actually lucked out. I can just subtract the tops. 28 minus 16 is 12. So that means I'm going to have 12 over x equal to 13 over x minus 1. And now I can just cross multiply. So I'm going to have 12 times the entire denominator. So I'm going to put that x minus 1 in parentheses. And then 13 times x is 13x. And so now I'm just going to distribute the 12. So I get 12x minus 12. That's the important step not to forget there. And then I'm going to subtract 12x from both sides. And these cancel. And I'm left with negative 12 equals 1x, which is the same as just x. So here, x is going to equal negative 12. So that makes my final answer B. This question reads, the force F of a gravitational attraction between two masses varies as the inverse square of the distance A between them. Given that k is the constant of probability, which equation describes this relationship? So when you have x and y and they vary inversely, or the inverse variation, that looks like the definition of that is y over kx. Well, here it's the inverse square, so that means this x is going to be squared. But we're not talking about y and x in this problem. We're dealing with f and d. So that means that we are going to have, instead of y, you're going to have f equals that constant k it talks about in the problem, And instead of x, our independent variable is d, so it's a d squared. So that's going to make my answer here A. Zoologists have been studying the population of squirrels. They've developed an equation which they believe models the number of these squirrels. If t represents the time in years and s represents the number of squirrels, what is the approximate number of these squirrels after 6 years? So basically, you're using this equation to solve for the number of squirrels after 6 years. So that means our t here is going to be 6. So that means anywhere that there's a t in this equation, I'm going to substitute in the number 6. So I'm going to have 125 parentheses plus 3, and that was a t in the equation. So now I'm going to substitute in 6, making sure to use parentheses, like always, around those numbers that I substitute. So then on the bottom, I have 1.25 plus 6. And then I just follow order of operations. So I'm going to take 3 times 6 is 18 plus 1 is 19. So I'm going to have 125 times 19. And then on the bottom, I can go ahead and add 1.25 plus 6 is 7.25. And then my next step is to do the multiplication on the top, which is 2,375, and that's over 7.25. And then when I do that division, I get 327.59, and that rounds to D, 328. This problem here wants to find the y-intercepts of this rational function. So remember, anytime you find the y-intercept, you're going to substitute in x equals 0. So that means anywhere that there is a 0, you're going to substitute in x and then solve for y. So here, remember, I can write f of x. I can change that to y. And I'm going to have, anytime I have that x, I'm going to substitute in a 0. And the reason I do that is because when you have the y-intercept, the x-coordinate is always 0, and then you have your number, that's your y-intercept for your y-coordinate. So on the top of this fraction, I have 0 minus 3 is negative 3, and then 0 squared is 0, plus 3 times 0 is 0, minus 1. And then continuing to simplify, 2 times negative 3 is negative 6, over negative 1 is positive 6. So that means my y number is going to be 6. And then it's an intercept, so my x number is 0, like we talked about before. So my final answer here is going to be A. Anytime you're finding a y-intercept, that x number is always 0. So that would have automatically eliminated B and C for us. Here we're finding the list of x-intercepts for the following relation. So this is very similar to y-intercepts, but when you're finding an x-intercept, you're going to make y equals 0 and then solve for x. So here, my f of x, that's the same as y. So I'm going to have y equals the 0. So that's 0 going to equal 7 over x squared plus 8x minus 2. So here I'm going to put a 1 underneath my 0 so that I can cross multiply and solve. So here I'm going to have 0 times anything is just 0. So that's just going to equal 0. And then 7 times 1 is 7. And that made my x's completely drop off. And I have a statement that's not true. 0 is not the same as 7. So that means that there are going to be no x-intercepts. Next, we're going to be looking at calculating the horizontal asymptotes of a rational function. So remember, a horizontal asymptote is a horizontal line that is not across, but it is approached as the graph increases or decreases. So it's going to get closer and closer to this line, but it's never actually going to touch it. So when you have a rational function, that means you're going to have a fraction. And so if the degree of your numerator is greater than the degree of your denominator, then there's no horizontal asymptote. So that would be like x squared over x. if the degree of the denominator is less than the degree of the denominator, then the asymptote is equal to 0. So that would be like x over x squared. And then if they are equal, so the degree of the numerator and the denominator are the same, then it's going to be the ratio of the leading coefficient. So that would be like if you have x cubed over x cubed plus 2, and we'll put a leading coefficient of 2 in the bottom. The degrees are the same here, so you look at the leading coefficients here. So I'm going to have, you have that invisible 1. So my asymptote here would be y equals 1/2. So in number 7 here, we're going to go ahead and calculate the actual horizontal asymptote here using the rules that we just talked about. Here, the degree is bigger on the bottom. And so since the degree is bigger on the bottom, that automatically means that my horizontal asymptote is going to be y equals 0, according to the rules that we just went over. So my final answer is C. Now we're finding a vertical asymptote, and a vertical asymptote is similar, only it's a vertical line that the graph will get closer and closer to, but never actually touch. And to find the vertical asymptote, you're going to set the denominator equal to 0. And so when I do that, I'm just going to take x plus 8, and I'm going to set that equal to 0. I subtract 8 from both sides, and x equals -8. And that's your vertical asymptote, so that's choice D. Now, this last two problems, we're going to take all the information we learned about the graphs, about finding the intercepts and the asymptotes, and to be able to match an equation with the graph. So looking at this graph, we have vertical asymptotes at x equals 2 and x equals -2 and x equals +2. So that means that this is going to get closer and closer and closer to those two lines, but it never actually touches. And here, it also has a horizontal asymptote at y equals 0, this line right here, because while it does cross here in the middle, on the end behavior, it's going to get closer and closer to y equals 0, but never actually cross it on the end. So it counts as a horizontal asymptote also. So I'm looking for problems here that when I set the denominator equal to 0, it gives me an answer of -2 and 2. And y equals 0 means that the top is going to have a smaller degree than the bottom. So all of these have, except B, where the degrees match, have a smaller degree on the top than the bottom. And so then looking at my denominators, if I plug in -2 and +2 here, that's going to give me 0. So A is right. C, this, if I put in +2 here, 2 squared is 4, minus 1 is 3. That doesn't give me 0, so it's not C. And then D does also. So now I have to look at which one of these will give me the correct y-intercept. So my y-intercept here is 0, 0. So if I put in 0 for x, that means I should get the point 0 for y also. So here in A, I put 0 in for x, and 0 squared is 0, 0 minus 4 is -4, and 0 over -4 is 0. So this one does give me that point 0, 0. That is my x and y-intercept. So it's going to be A, because whereas in D, I have 0 plus 1 over 0 squared minus 4, which we already said was -4. And that's 1 over -4, and that point isn't on my graph, so it can't be D. Once again, I'm putting together all of my information that I know about y and x intercepts and horizontal and vertical asymptotes. So looking at here, I'm going to see there is a horizontal asymptote at y equals 2. So looking at my choices here, all of the choices have the same degree in the top and the bottom, so that means I'm going to look at the ratio of their leading coefficients. Here I have a 2 over 1, so that one checks. B, I have a 2 over 1, so that one will check. C, I have a 2 over 1, so that one checks. D, I have 2 over 2, which simplifies to 1. That's not my horizontal asymptote, so it can't be D. Okay, and then I notice I also have a vertical asymptote at x equals 0. So that means that if I have put a 0 in for x in the denominator, that's going to make the denominator 0. So here, x is 0, so that makes the denominator 0, so it could be A. B, I have a 0 in the denominator if I substitute in x, so it could be B. C, I would have 0 plus 1, that's a 1, I can't have that, so it's not going to be C. That doesn't make the denominator 0 for a value of x. So then my last part is going to be to check out my x and y intercepts. So I see that I don't have a y-intercept because that's the asymptote, but I do have an x-intercept at 1/2, 0, or approximately 1/2 at least. We don't know, maybe it's 1/3. So we're going to look for which one of these has an x-intercept somewhere around 1/2. So remember, to find your x-intercept, you're going to substitute in 0 for y. So A, I have 0 equals 2x minus 4 over x. I'm going to put a 1 over my 0 and cross multiply. So 1 times anything is itself, so it's going to be 2x minus 4. And then 0 times anything is 0, so 0 times x is 0. And then I'm just going to solve for x here. So I'm going to add 4 to both sides, and I get 2x equals 4. And then I'm going to divide both sides by 2, and I get x equals 2. And so this one has an x-intercept of 2. So that's definitely not a 2 there, so it can't be A. Now let's just check B to make sure that we didn't make a mistake. So I'm going to have 2x minus 1 over x equals 0. I'm going to put a 1 over my 0 and cross multiply. 1 times anything is itself, so it's going to be 2x minus 1, and x times 0 is 0. And then I'm going to solve this. I'm going to add to both sides and get 2x equals 1. Divide both sides by 2, and x equals 1/2, which is the x-intercept. So that means B is definitely my answer. Everything checks out. Well, thank you for joining us today, and I hope you learned something new.